Well, as usual, we're back again. And as usual, if you go look at the description below the YouTube video, you open up that description, it's got the index of this meeting is indexed, and it's got a link out to our composite index that has several years of the index just all stuck together. And you can search that for whatever you're looking for. And you can, from there, you can directly click on a link and go watch a video if it strikes your interest. And then there's other things in there. We've got a link to our Slack channel, and I've got a link to my original ROS agriculture stuff that I was indexing. So that's if you're interested and you go look at that stuff. There's also a link to the YouTube page where it's got all of our videos that we usually on a weekly basis we make a video and we put them out there. So that's enough of that. I don't know if I mentioned on the video last week. If I mentioned on the video last week that they were going to come inspect my apartment, I think I did mention that. And it turns
You
out
did. Yes, you did.
and it turned out it was no big deal. They just showed up and looked at the smoke alarms and wrote down some numbers on them, looked under the sinks to make sure there's no water leaking there, and that there might be something else they did. And I made a whole list of things. Oh, by the way, this is broken. This is broken. So they were here for a while and they left, and then after they didn't say anything, say, oh, you shouldn't be doing this or you need to get on that. So anyway, that happened, and it wasted several days of my life because I was agonizing over what was going to happen, but it came and went and wasn't a big deal. So one of the things I was, last week I was saying I was playing with my that temperature logging and my current logging on my refrigerator, and I thought, well, I'll merge those together and play with it, but I didn't want to set that up and have it running when these inspectors came to look at stuff because I figured they get touchy about that. So it turns out a couple days went by and they didn't show up. So over the weekend I had time, so I set this stuff up, and I'd merged my temperature into my current logging and ran the thing. And let's see. So the results of that were that this is so the last few weeks I showed one on my show that I could see the current and the voltage and all the stuff on the by monitoring their AC. And in this particular plot, the blue one is the power, the power from the AC. So when it's normally run draws about 110 watts. And then this up here jumps up to 400 watts, which is like we decided it's probably a defrost cycle. And there's various other things going on. But this time I had it composited or it actually collected the current and three temperatures. The top temperature is just room temperature with a sensor laying on the countertop. And this orange one is the air temperature inside of the refrigerator, and the yellow one is the air temperature inside of the freezer. And again, I ran this all night, and you can see things like over here. I open the door and the power goes up by 40 watts because it's got a 40-watt light bulb inside. And then you can just see the compressor cycling on and off. And I thought, well, it still seems to be fairly drastic temperature change in there, but I realized that's just the air temperature. That's not the temperature of the food. So when I get around to do some experiments, I might grab this green sensor and tape it onto like a pop can. And so a pop can that's full, unopened one, and let it cool down. And then when I run it, I'm assuming I'll just get a line across here that's going to be almost a solid, just a constant temperature, even though the air temperature is going up and down inside of the thing. And speaking of air temperature down here, when it's going through this defrost, it came up, and here I had opened the door. Here's an extra thing saying the door is open, and you can see that the air temperature inside of the refrigerator comes up pretty quick. And this whole time the compressor is running, so I close the door and it pulls back down. So just interesting things like that I can look at. And after I ran this all night, then how do I get to the next one here? This one. No, that was no, this one. So then directly after I got done with that, I shut it off, and I just thought, well, let me play with a couple things here. And I opened the door, and at a 10-second sample rate, and it probably saw right out of the middle, it caught that it was open, and the next sample, it was off again. So it got a little spikes and the door was open. And while the door was open, you can see the temperature was coming up fairly quickly, and then leveled off. And then here, so the compressor's on, the compressor's running. I've got the door open again, so you can see again the temperature starts The temperature jumped up fairly quickly there. I closed the door, and while the compressor's running, the temperature, it amazed me that the air temperature inside the refrigerator just followed the current down almost exactly. And that's the first time I've seen it do that. And then later on, I thought, well, let me open the door again. I did, and the temperature came up. It started to cool back down a little bit. And I opened the door again and propped it open. And it came way up here. And I closed the door, and then again, it's just pulling the air temperature down. So anyway, I've got stuff I can look at if I want to go play with it now and try to analyze what it's actually doing. And I did this I did on the weekend before, because the inspection people showed up on Monday, and once they left now, if I want to go set this up and run it all the time I want. So that's what I was doing on that. And that's, other than that, that's about all I've done. I since I had to move stuff around and clean stuff out, I found some more fun stuff to look at. I may that might inspire me to do something too. But oh, I also ran there's a timing problem on that Python program, and I was explaining to Al before we started recording. There's something about the way he's deciding when to do a sample, and I don't, it could be the problem's always been there. It's just that he logs everything as samples. So one column says time in seconds, and it either goes 1, 2, 3, 4, 5, 6. If you're going to set to one sample, 1 hertz sample rate. If you got it set to a 2 hertz sample rate, it says 1, 1.5, 2, 2.5. So you don't get the actual time. You just get increments from when you started. And I assume when it opens the file, it'll put a timestamp on. So if you really wanted to, you say, okay, started at 6 p.m. and then 3,000 samples into it, figure out how much time that is and add that on. But so what I did, I just modify it. So I just grab an actual timestamp, grab the time of day and put that as my first column. And that way, when I go plot it out, I know what the times are. And that turns out the fact that once I merge the temperature in with the power monitoring, apparently those Dallas one-wire sensors take a finite amount of time to read them, because it's adding like an extra 2 or 3 seconds to each sample time. So if I set it to 10 seconds, it's actually giving me randomly like 12 to 13 seconds between samples. But since I had a timestamp there, I still know what time it is, and I'm not losing anything on that. So I need to look into that. And those Dallas sensors, there are various things. Maybe I could start up a thread and just have it constantly sampling those, and just store those as a static variable. So when I say read the sensor, I'll just bam, grab all 3 of them, and that won't affect my time at all. Or I might be able to, since he's always sampling at a 2 hertz rate on the sensor. So I could just say, read the AC power monitor, and then read a temperature sensor, then increment the pointer to the temperature sensor. So 3 times through the loop, it'll have all the current values, again, just sitting there, so I can just grab them and do whatever I want with them. So that's something else. If I get around to it, I might go back and modify that a little more and play with that a little more. And other than that, I may just leave it in the box and never touch it again too. So that's another option on that. So I think that's all that I have to say for this week. So we'll turn it over to Al.
Reminds me of the box that, what is it, a box or a list of things that we're never going to do that we keep putting things in? I've forgotten.
Both. I think there's both.
Well, let's continue the dialogue around monitoring power related stuff. I have in my backyard an RTK base station, and this is in my Miro board, and there's a solar panel going into charge controller, which has also got a 12-volt battery and an RPi and a GPS and power conversion deal, and got an ESP32 here to keep track of data that's in this charge controller, coming out of this charge controller. And a couple of weeks ago, we were talking about.
Before you move on there, if I were to go out to your Miro board and want to post a link to what you just showed, can I say Al's Miro board and then give like a name or something, and it'll bring up that exact thing? Does it work that way? Or
You can, if I have
I thought somewhere
Me,
you had a section that you had an index, and
yeah, I think there is a way for me to assign this box a link. Um, Give me some time to spend on that. I think there is a reference that I can give this box and then link it later, like I have a documentation deal. I had an index.
yeah, I thought you had one. I just didn't know if it was, convenient to just if you had something right now, you could tell me, and if not, I can also log in and poke at it and see if I can figure it out too.
Yeah, I'll have to look for it. I did have an index and
Yeah, now you need an index to point to your point to where your index might be.
that's exactly right. Um,
If they giving you a crap about you're using up too much space for a free account,
I have not.
because Bob went through that. Bob signed up for this, and he's going along, and he ran out of space, and he started whining around. He's okay, well, we'll give you more space. Maybe they just turned it off. I don't know. Just more tidbits from the past that I remember going by.
Yeah, I'll have to double check and see if I can find it. Oh, there is it. That's documentation links. Finally, he finds his documentation links. Um,
What's one of those links look like? If you is this stuff on your page? Is what those are?
well, like this, you might not be able to see that at UDev rules. I have a link and it gives me a link to click. And if I go to that, it brings me to the UDev rules.
Okay, so probably if you right click on that box, it'll just say, what's the
Yeah, what I've forgotten is how do I extract or apply a link to this box? But um,
okay. I'm just curious if you had it handy. If not,
oh yeah, there it is. So
link.
when I click on the link and if I click on the
Okay,
three dots, I can get a copy link. And then if we're lucky, that goes back to the documentation links.
yeah,
Yes. So you
okay,
can get from and to.
yeah. So I may or may not try to add that in the description to point to that, because I assume if I can people view this if they're not a member of your Miro board, or do they have to be? Do you have to give them permission before they can go in and look at it? Or maybe
Uh,
maybe you don't know since you're not. You know,
Yeah, my recollection is you just um well, now it looks like they might want your email address. Oh, copy board link. Anyone with link can do viewer. Let's put it in. How do I get back to chat? Chat, chat, chat. Where are you, chat? There you are, chat.
so for anybody that's watching this and wondering what we're talking about, this is a free whiteboard you can sign up for, and you can get it for free and you can use it for a while. They might give you a hard time. They want money for it if you want to add more stuff. But Al says he's got all this stuff on here and they haven't been harassing him about that. So if
Anyway, I
you,
put in the chat the link to the board. See if you can click on that without
well, the thing is, but I have access to your page, so
oh.
that's not gonna help. So anyway,
So I was working on my LED and trying to figure out which statuses I wanted to report on and how did I want to report on. We talked about that um, last week, and I had this initial list of events and what I wanted to have on and off. And so I continue to work through that. And I was not getting any RTCM corrections coming through. And I'm like, well, that's annoying. And come to find out, my battery had died. And so I started mucking around with my RTK base station power usage and battery. And lo and behold, the bottom line is I need a bigger battery or a better battery. I have a 3-year-old lead acid battery, and it's dying in the middle of the night. And then they are, around 9 o'clock, the sun comes up and starts feeding enough juice into the end of the system where the battery wakes up, and then the RPi wakes up, and then I start to get correction data again. So anyway, that I'm working through changes I need to think through about how do I keep enough power in this thing. And Jeff had suggested, well, turn off your power, silly. And yeah, I can do that. It takes more circuitry that I haven't implemented yet, but I do have this ESP32 out there that could monitor. And that's part of the reason I was interested in. Jeff had some real-time clock stuff that he was looking at on these RPi 3s. And so if I just had a cron job to say shut down at whatever 9 p.m., I don't know how to wake it up without a real-time clock. So that would be probably the simplest way, is put a cron job in to do a pseudo shutdown, and then whatever that RTC gives you in the way of ability to fire it back up would probably be the simplest way to implement that. And then we could all think of other more complicated ways, like using the ESP32 to drive some relay that turns it on and off. But at the moment, I'm waiting for the sun to come up and get enough power on it to wake things up. And I could get a new battery too, but haven't done that yet. So any thoughts on real-time clock?
Before we go on to that, you also got the option. You could just manually walk over and turn the thing on when you want to use it. And then when you're done for the day, just turn it off again. And then it should have enough, several days worth of battery charge on it.
Yeah,
Because
what you have,
your thing looked like it was going along just fine. And then it started draining at the end out there.
what you don't know is the box of this stuff sits in is jammed into the corner of a yard shed, and there's a bunch of stuff. So it's not, it's sort of like a deep, dark cave. You don't want to go into it very often.
Yeah. Okay.
Um, so what else was I going to mention? Oh, let's see. Also on my Miro board, in trying to work through my LED, sort of managing the LED lights, I decided I was going to have a separate Python program dedicated to, managing the status of the LED, and it would read some status stuff on one of the UDP ports, and it would also read port 6002, which is where the RTK data is, well, some RTK lat-lon data is being published. And so I've put a little bit more documentation out on here on the Miro board. I've also, we've talked before about micro ROS, and I don't have micro ROS installed, so I've got to have some sort of code to pass data back and forth between the teensy and the RPi. And so I've nominally got a program that I'm just calling teensy serial bridge, and it's not done by any stretch of the imagination, because I got a sample or a draft put out there, and I was trying to test how fast this thing could run and how fast I could get data back, with the assumption that there's going to be some command velocity data coming back from the RPi. And I just took a draft program and tried to push data to the teensy at like 20 hertz, and I haven't successfully done that yet. So that's where I'm at the moment, is a little bit working on my LED controller, a little bit working on my serial bridge in order to plan for the day when I can get my LED statuses worked out. And one of those is going to be, am I getting command velocity data at a rate that I'm happy with? And I'm thinking about doing that at 20 hertz, since that's what the GPS is working at. The other thing that's probably worth mentioning is, in this process, I was just using PowerPoint to, like, okay, I'm going to have the teensy over here, and I'm going to have the RPi here, and I'm going to pass this command velocity stuff. And I'm like, well, that's not a very nice way of doing things. And so I found this software called Mermaid, and I guess it's a way to use text to describe boxes, and then you can render the boxes in a browser or on GitHub or something like that. So at the same time, I've been putzing around with this Mermaid language, I guess is the best way to put it. And so I'm thinking at the moment, and I had to do this, well, I designed this, or I wanted to lay this out because I was trying to wrap my head around, well, what data do I absolutely have to push to the teensy, and what's not shown here is data going back up into the RPi, but that's what triggered all of this. So
Before we move on here, you just made the comment that you're going to write that Python node, and it's going to handle. You said the GPS is running at 20 hertz. Are you saying it's putting out? This is on your vehicle, so you're putting out like your latitude and longitude at a 20 hertz rate.
yes.
Because if you look at your board, it says if you want to run 20 hertz, you can only use GPS. You cannot use Galileo and whatever the other ones are, GLONASS. You can only run GPS if you want it to run at a 20 hertz rate. Now, if they say you can run at I think you run 3 constellations, you can run at 10 hertz rate, or was it 8.5? There's something about 8.5 hertz too. But don't overdrive the thing, because that may give you bad results if you do that.
Okay.
So that's just something to keep in mind on that.
Yeah, I'd have to go back and remind myself what these things are configured at, and confirm that it is actually running at 20 hertz, but that was what I was hoping, I guess. I will label it as a hope, not an actual fact at the moment.
But if you're going to dig into that, you might look and see, because if you really do want the faster rate, and if you really can only look at the GPS satellites, you can say, figure out some way to decide, is that giving you adequate, or is it going to work out for you, or do you have to, to get better resolution, or a better position, maybe you have to run 2 or 3 of the constellations for it to give you a better solution. But then when you do that, you have to slow down the output rate. You can't run it at a full 20 hertz, I believe, is the way that works.
Okay. Yeah, I have to, as with a lot of things, when I step into it, I'm like, I have to go relearn that. I've forgotten off the top of my head how this is actually configured. Let's see. So that's where I'm at the moment, is working through trying to get my LED programmed. Part of that is correction data and getting fix and reporting all of that. And part of that is working through how how I want my teensy to RPI bridge to work. So I've struggled at getting that to be as fast as I want it to, and so I'm trying to fix that at the moment. That's where I'm at on my. I was going to mention. Yeah, let me turn sharing back on. So in my GitHub at the moment, the way I've structured it is I've got in the main branch code for the base, code for the radio control, code that's going to sit on the tractor RPI, and code that's going to sit on the tractor teensy. So, and in the tractor RPI, I've got the LED controller and the RTC M server that's outputting the lat lon data, and then the teensy serial bridge that's going to try to pass data back and forth. There's some other stuff in here, but yeah, I am coding in the open, as they say. That's it for me.
Yeah, Bob said he was out to the dentist today, so he's not going to be presenting anything. He put some pictures up. I didn't know if it's worth showing his pictures or not. And maybe we'll just wait till next time he can tell us all that stuff. Oh, as I'm sitting here looking at the Slack channel, I was looking at that stuff you were posting about your logging stuff. Something you could consider is if since you got an RPI as part of your base station, as you're converting the stuff and you're outputting, I think you were just keeping like you said, you're keeping a record of everything, and at the end of the day, you would download that to your computer. You could have it, as you're doing that conversion, just strip off the values you want, say like, um, I'd say voltage and so voltage on the battery and a couple of things from your charge controller to say whether you're charging or discharging, and just simply then just open a file on your RPI and just actually write to the flash card. So you just just build like my data logger is working now. So you just grab a few values out of there you want, and then just have have it create a file on your flash drive on your RPI and just write that stuff out. So it just it just keeps getting bigger and bigger. Mine actually cycles once a day, but then you come back later and it'll have that file will be there. You can go look at the file. So it's not a matter, you don't have to retrieve it to your other computer to do something with it. It would just be there. In a week you can go back and say, oh gee, what was the stuff doing during those cloudy days? You could just pull it up and look at it that way.
Yeah, I think I was enamored with the fact that I could create a CSV on the ESP32 and then pull it down, but you're right. I mean, this is the kind of data that's available as the temperature and voltage and what it calls state of charge, or thinks the state of charge is, amps, solar panel voltage. I mean, so there's all this data. My issue was, as you noted, is it sort of fails if I don't download it. I get one shot at it and better do it right. So I could definitely increase that. But so this is an example of, you can't tell it by that timestamp, but this is when the voltage of the solar panel came up high enough that the RPI could turn on, and the last record of the day, or at the 8 p.m. record, the voltage was down to 12.5. So there's no sun coming in. And so what I don't know as I sit here is at what voltage does it fail? And you're dead right. If I logged this more, I would have a better idea of that. But it gets down to on this day, 52 degrees, and the voltage was at 12 and a half at 8 p.m. when it did download this. So the data's there. I just have to change my approach to logging it.
At this point, does your ESP32 talk to your Raspberry Pi? So you could, take these values and send them to the Raspberry Pi, or is that not connected at this point?
Well, they're physically connected, but they're not moving data, in real time or near real time. They're only moving data once every 24 hours. So there is a physical, there's a USB cable that runs from the ESP32 up to the RPi. I think did I plug it in there or did I plug it in here? I've forgotten where I plugged it in physically. But yes, I can get data off here. It's just I only do it once every 24 hours. I have a
And
cron. I have a cron job on this RPi that goes and pulls the data off the ESP32.
okay. What's the other thing I was going to say? Oh, you want to be careful because, if the power is coming down and it just simply at some point says, I give up, I'm going to quit running. You may have a problem on your any of your controller boards if you're putting too low of a voltage into them. That may either confuse them or burn up its power supply or something. So you might want to give that a little more thought too, as to if you get below a certain point, just have it turn the power, just put a relay or something, turn the power off completely, and then don't just have it kind of the power fluttering up and down, because that may, if nothing else, it's probably going to eventually take out the data on your Raspberry Pi. It's going to confuse the flash, and you're going to lose it's going to screw up your file system by doing that.
Yeah,
So yeah, if you have a better thing to say, okay, get down to the point, just tell the RPi to shut down and then kill the power completely, and then wait till the voltage comes back up, and then have it restart. You probably have less chance of damaging your RPi by doing that.
yeah,
And,
that's
and the
putting it
ESP32,
mildly.
I don't know what kind of problems it would have, but so that
You're
that's just you can put those things on your list as you're going through trying to solve these problems. Say, well, that would be, a better way to just have it. If we get down to a certain point, say, okay, we're going to give up. Just go ahead and kill all the power, and that way, because also if you keep discharging your battery down below a certain point, it's gonna damage your battery too if you're drawing power when it thinks it's dead. So that'd be another reason to just have it kill that completely if you could. So just more things to think about as you try to redesign this.
all good points. I am absolutely on the. I'm flirting with catastrophe. Is another way to put it by letting this thing crash the way I am. It's not elegant at all.
Yeah.
That's what's going on here. I do think it would be interesting to pull up Bob's pictures.
Well, let's see if I do this. And so Bob is saying, here's what he's doing. And let's see, he says, making some progress. I'm using carpet tape under switches and lever wago nuts to help hold them in place. Next, he's going to extend the short wires.
You're not
And
sharing if you meant to be.
oh, here, I did mean to be, and I thought, oh, just dragging her over there would fix it, but apparently not. So let's see, desktop 2. So here is there is the page. And he was saying that he's making some progress. He says he's using carpet tape under the switches. But when I looked at it, I thought he had like a double backed sticky stuff, but it says it's double sided and somewhere says permanent. So I think it's the stuff you have to heat it up and get it to glue itself down. Here, let me zoom in on that. So here's his tape that he's using. And I think this is what you do is you put it under your carpet, then you got like a tool that heats it up. It's kind of like hot glue. So you heat it up and then press the carpet together that's what this stuff is meant for. So I don't know if that's what he's actually tried to glue the switches down with this or not. But anyway, he was mentioning he might use this stuff to glue his switches down. And then he's got, here's an example where he's got a, well, that's a clever way to hook those down. He's got Molex connectors. He's put some straps over with screws to hold that down. So this, I believe, is his power driver board or his motor driver board. So he's got RC input, and then coming out of that, here's his two motors, and then he's got these. This is the motors on the physical vehicle right here. So he can take this whole top section off and move that between his indoor test platform. Then he got his outdoor Barbie Jeep, and he wants to be able to take the thing off one and put it on the other. And so this is just close-up pictures of this is his, he unplugs that and he can pull the little top piece off. And then here's one of his switches over here. I see he's just got a strap holding that down too. So that's, I guess I never would have occurred to me to do that. I typically I'd make a piece of aluminum angle and cut a rectangular hole and snap the Molex connector into it. But this looks like, if he puts the tape underneath to hold it down, whether you use like a double back foam sticky tape or that stuff he's got and glue them down permanently, I guess that might work. Then here's some of those WAGO connectors that he's hooking stuff together with. And this back here, that looks like a relay, I think is what that is. So anyway, that's one of his close-up pictures. And then here's his, here he's talking about his 3 switches. So the motors, he's just got, I think he ended up with 3 batteries on his system here. So see this red and white wire coming down goes to this battery or this switch, which then powers the converter for his Raspberry Pi. And these 2 come down, and he's got another converter to give him 5 volts, and that's what's running his servos on his thing. And at the moment he's maybe he's going to show us that. So anyway, he's got the 3 switches across there, and these may or may not light up. I don't know. I think maybe that extra terminal on the back, you could light these up if you really wanted to, but I'm sure they have incandescent lights and they're going to take a lot of power. For all I know, they might have LEDs inside of them. So anyway, here's 2 of his batteries right here. And he's got this aluminum bracket that's keeps them from sliding around. And then I think in the next picture, he's going to show us the straps that he's got. Yeah, so he's got these aluminum angles to basically form a battery box. He's got a board stuck in between to keep them moving around. Then he's got these bungee straps over the top to hold them down so that it doesn't bounce around and have them come out. So here's this big battery for the motors. This is one of the Power Wheels motor batteries. And I don't know if that's a 6-volt or 12-volt battery, but he's got that. And as I say, that looked like a relay down here. Somebody's controlling a relay running in his whole motor drive circuit. But he's got his intent was he wants to be able to unplug these or disconnect these bungee straps, and he's got these WAGO connectors in between. So he's got these permanently stuck on the battery here, and then he's got this connector, and I think he unlatches that and takes the wires out. And I think in the long run, you'd be better off having like a polarized connector, kind of like the one. Let's back up, like this, where he's got a polarized Molex connector with wires in the right spot. So you just unplug it. So maybe unplug all the batteries at the same time, or each battery could have a 2-terminal one. Because if you got just random things you're hooking up and connecting and disconnecting every time, as I was saying last time, eventually you're guaranteed you're going to hook them up backwards sometime. You're not going to be thinking you're going to put it on the wrong one. The first indication you'll have is going to go bang and you're going to have smoke. It's like, oh, I shouldn't have done that. So anyway, he said he's got here's a close up of that where he's got the push on connectors on the battery, and then he's got these connectors here so you can, but it's still, you got red to red and white to white, so it's harder to screw that up on these batteries. Sometimes you don't they got a little red insert here that they poured in, so it does give you an indication, but if you're not paying attention, you can hook those up backwards. So that this is better what he's got. But he's saying he's got a Molex connector on order, so I assume he's gonna, coming off here, like right here, he'd put a 2-connector polarized Molex, and that way when you go to plug it in, it'd be much harder to screw it up that way if you do that. And I don't know if there's anything else. That's pretty much that's a close of what we're looking at before. That's the end of his pictures that he had. So he's saying that's where he's at right now, and he's waiting on parts, or maybe waiting on money to buy parts. I don't remember which that was. So let's see if I stop sharing that. Okay, so that's kind of a quick update of Bob's stuff, since he's not here to tell us what he's doing. And I don't know if there was any other Well, where did my screen go? It's gone now.
I'm all set.
Okay, I think I'm done too. So let's see, I'm not sharing, right? So let me do this. Let me do this. And come back to here and I'll see if I can say stop recording.